All right, so today we're doing IA 221, and we're looking at PNP versus NPN sensors. And we're going to focus on 3-wire sensors, though we will touch on 2-wire as well. 3-wire sensors have your 2 power wires, 0 volt and plus 24, or 0 neutral and 120. And then you also have a 3rd wire that's used as your signal wire. Now we're going to focus on DC sensors. So for this discussion, NPN versus PNP, we're going to focus on the low cost 24-volt sensors, which are most typical for most worldwide capacitive and inductive proximity sensors. So now the most important thing, and I went through this with most of you in the labs, when you see a load symbol on a sensor, that load symbol means that's where you wire in the PLC. So that's an important thing we got to remember. The load is the PLC. Load is the PLC. So first of all, let's talk about 3-wire sensors. They're kind of classic. I think they're very common. And this is a typical 3-wire sensor diagram, normally open configuration. How do I know it's normally open? Because I show that little switch symbol there, where you got the little switch symbol in the drooped position or the open, normally open position. I've got 3 wires in there, and I don't mention the wire colors in this diagram, but maybe I should add that. Let's add the wire colors. All right. So we're going to insert a wire color here. So what is a typical plus 24 wire? It is brown. All right. What is a typical 0-volt wire? It is blue. Let me get a lighter blue so it shows up better. All right. So my plus 24 is typically brown in almost all European, Chinese, and most sources, even in the US now, they're going to use plus 24 blue and, I'm sorry, plus 24 brown, and blue is 0 volts DC. All right, those are your 2 most important wires for that sensor. They power up that sensor. A lot of the sensors have little LED indicators to say that it's powered up. Some of them don't. Some of them only turn on when they turn on. Some of them have no indicators at all. Depends on the sensor. Okay, so a typical sensor like this is going to have this wiring diagram. And so there is the sensor. If you ask me, Rob, what is the diagram for a typical proximity sensor? This is what I'm going to show you. Actually, I expect you to know it yourself. Your power wires are going to be blue and brown. The 3rd wire in there, in the diagram, goes to something called the load. And that load, usually at the back end, at the front end, the part facing the sensor, it just shows it connected to the sensor. On the back end, it's either hooked up to the brown wire or the blue wire. For NPN sensors, the back end of the load is always hooked up to the brown wire. Because NPN sensors mean that when it turns on, energy flows from the load, the plus 24-volt throws through the load back into the sensor to turn on. So if I'm wiring up a PLC, this is how I would do it. I would pop my sensor in, give it plus 24 volts, give it 0 volts. Yay, now my sensor can power up. Then I'll take that 3rd wire, drop it into an input. Am I done? No, because for a sensor to give that PLC a signal, that PLC has to have energy flow through the input rail, which means I need to wire something up to the input common. And the thing I'm going to wire up to the input common is the plus 24 volts, not the 0 volts. So an NPN sensor has a plus 24 volt wire going to the input common associated with the input I'm using. All right, so that's the classic way of wiring up an NPN sensor. Now, a PNP sensor is nearly the same. You got a sensor, you got your power wires, but you got your load. But instead of having that load hook to the backside of the load hooking directly to the plus 24 volt, now the backside of the load is going to the 0 volt. So from a PLC wiring, it looks exactly the same, except one thing. You got your sensor, you got your power wires, you got your input still going exactly the same way, but now the difference is this. Instead of hooking up to the plus 24 to the input common, now I can flip my input common to my 0 volts. And this is why many PLCs have they have groupings of their inputs, each with its own separate input common. That way I can have all my NPN sensors go to one group of inputs and all my PNP sensors go to a different group of inputs. So this is a very common way of doing that. So if we want to talk about two-wire sensors, they are very similar, but we don't have to wire up a separate power wire for the sensor. We send one wire to plus, one wire to minus, but then instead of having a third wire for the load, we can stick our load in the middle of one of them. So this is a typical, normally open two-wire sensor. So there's my power, then I have my input, and then my common goes to 0 volts. So this is a typical two-wire sensor. So the energy flows through the sensor, through the input, through the common, back to 0 volts. And that way I can use just two wires out to that sensor. All right, and you could also have NPN or PNP sensors, so you can flip the direction of the flow either way. But that is all I want